Hello friends, in this video we are going to discuss about wireless sensor networks. Now let's see introduction about wireless sensor networks. Wireless sensor networks are changing the way we collect and analyze data. With wireless sensor networks, we can monitor and analyze data in real time, making it easier to make informed decisions. This video will provide an overview of wireless networks and their applications. Like it consists of distributed and independent sensor devices that monitor and record the physical or environmental conditions of the environment and forward the collected data to central location.
Now see the architecture of wireless sensor networks. It's the way the sensor nodes are organized and communicate with each other and with the base station. There are two types of architectures used in wireless sensor networks. One is layered network architecture and other is clustered architecture. Layered network architecture is the architecture that follows the OSI model and consists of 5 layers. The physical layer, the data link layer, the network layer, the transport layer and the application layer. It also has the three cross layer, the power management plane and the mobility management plane and the task management plane. This architecture is suitable for small scale wireless sensor network with a single base stations and few hundred sensor nodes. And in cluster architecture, it's based on the two-tier hierarchy where sensor nodes are grouped into clusters. Each cluster has a cluster head node and that acts as a leader and coordinate with communication within the cluster and with the base station. This architecture is suitable for large-scale wireless sensor networks with thousands of sensor nodes and multiple base stations. This uses data fusion techniques to reduce energy consumption and improve network performance. Now see what are wireless sensor networks. Wireless sensor networks are networks of small devices equipped with sensors that are distributed over a certain area to collect data. The nodes communicate with each other wirelessly to form a network. This technology has applications in various fields such as agriculture, healthcare, and environmental monitoring. And also, these networks of specialty disposed and duplicated sensors that monitor and record the physical or environmental conditions of the environment and forward the collected data to the central location. It have many applications in areas such as Internet of Things, environmental monitoring, medical monitoring, agriculture, and landslide dedication, and etc.
Now see advantages of wireless sensor networks. There are many advantages to using wireless sensor networks. They are energy efficient. Wireless sensor network consume less energy compared to traditional wired networks as they operate on batteries and do not require physical connections. Wireless sensor networks also use data fusion techniques to reduce data transmission and processing. Second one is it is low cost. Wireless sensor network consists of small low cost sensors that are used to deploy, making them cost effective solution for many collections. WSN also eliminate the need for wired connections, which can be costly and difficult to install. Third one is flexible. Those are adaptable to different environments and applications. It can be deployed in various topologies and configurations such as star, tree, mesh, or hybrid. It is also reliable and secure because it is resilient to node failures and network disruptions. It can be used self-organizing and self-healing algorithms to maintain network functionality and performance. It can also provide real-time monitoring, which is crucial in many applications. By using wireless sensor networks, we can also reduce the need for human intervention in data. Now see the different applications of wireless sensor networks. They have many applications in various domains and scenarios. First one, IoT, Internet of Things. Wireless sensor networks can be used to connect various devices and sensors to internet and enable data exchange and analysis. It can support IoT applications such as smart homes, smart cities, smart agriculture, smart health and smart industry. Second application is surveillance and monitoring. It can be used to monitor and detect various events and activities in target area. It can support surveillance and monitoring applications such as security, threat detection, wildlife observation, traffic management, and disaster response. And third one is environmental monitoring. It can be used to measure and record various environmental parameters and conditions in specific region. It can support environmental monitoring applications such as weather forecasting, air quality monitoring, water quality monitoring, soil moisture monitoring, and landslide detection. And the other one is medical monitoring. It can be used to monitor and record various physiological and health related parameters of patients and individuals. It can support medical monitoring applications such as patient tracking, vital signs monitoring, wearable devices, and implantable devices. Wireless sensor networks can also help us monitor air and water quality, track animal behavior, and detect diseases. In industrial setting, it can be used to monitor equipments and optimize production.
Now see, what are the different challenges of wireless sensor networks? Despite their many advantages, wireless sensor network can also face several challenges, such as limited power supply. It are typically composed of battery powered sensors that have limited energy resources. This makes it challenging to ensure that the network can function for long periods of time without the need of a frequent battery replacements. And the second is security. WSN has are vulnerable to various types of attacks such as jumping, spoofing, replying, alerting, and injection data. Security is a crucial challenge for wireless sensor networks as it affects the data integrity, confidentiality, and availability. Security mechanisms should be designed to cope with the resource constraints and dynamic nature of wireless sensor networks. And third is scalability. It may consist of 100 or thousands of sensor nodes that are deployed in large and dissolved areas. Scalability is a significant challenge for wireless sensor networks and it affects the network management, communication, protocols, and data processing. And the next is data aggregation. It generates large amount of data that need to be transmitted and processed efficiently. Data aggregation is a vital challenge for wireless sensor networks as it affects the network bandwidth, energy consumption, and data quality. The design of wireless sensor networks must take into account these challenges to ensure their success. Now see the closure of wireless sensor network. Wireless sensor networks are networks of specially dispersed and independent sensors that monitor and record the physical or environmental conditions of environment and forward the collected data to the central location. It may have many applications in various domains such as IoT, surveillance, environmental monitoring, medical monitoring, and more. It also faces many challenges such as limited power and energy, security, scalability, and data aggregation. It can emerging and promising technology that can provide innovation solutions for many problems and keep watching guys. Thank you.